So next, let's try this. And this time I'm going to play a small trick with you. And this time I'd like to see whether you can spot the longest chain correctly or not. If you spot the chain correctly, you'll come up with a different name. If you spot a chain incorrectly, of course, you're going to end up with an incorrect name. Go ahead.
Okay. When the parental branch, should I make it separately or together?
What
Like,
separately or together?
like this. Sorry. For the parent chain, like this part, is it like this or like this? Like sectionally divided.
No, no, it's the whole thing, of course. But remember, you need to pick the chain with the maximum number of carbon atoms as the parent chain. And
Ah,
then the
so
rest of
this
it
one.
would become the branch. Just like I told you yesterday. So what if I tell you your bifurcation for parent chain and branch is not correct?
Because CH1 CH3 it's less than the
Yeah,
I don't
your
know.
parent chain actually consists of 5 carbon atoms and your branch
Yeah,
consists of 2 carbon atoms.
two.
Well, what you can do is that you can go for a longer parent chain, and this can be your straight longest parent chain like this, and then this can become the branch. Why are we doing it? Because now my parent chain has 6 carbon atoms and my branch has 1. So try
Can we?
making a parent chain with the longest parent chain or with the maximum number of carbon atoms, but they have to be straight. Straight means that they are connected with the help of bonds. Straight doesn't exactly mean they should be in a horizontal line. I hope I make myself clear when I say it like that. Make sense?
Wait. Can you repeat it again?
Yeah. What I'm trying to say, the point I'm trying to make is that your parent chain, and I'm going to number it for your understanding. Your parent chain has 1, 2, 3, 4, 5 carbon atoms, right? But my parent chain has 1, 2, 3, this one's 4, this one's 5, and this one's 6. 6 carbon atoms. So my parent chain is longer than yours.
Yeah.
So my point being, the parent chain doesn't have to be horizontal. It doesn't have to be vertical. The parent chain can be something
Oh,
like this, or something like this, or something like this. It can be in any direction, but it has to be connected with single bonds. Like this one is connected by a single bond, this one is, so on and so forth, right? Make sense? Okay. So let's try it now, as this one is already, but in fact, let's check whether the numbering is correct or not in my case. Since I already marked the whole thing for you, so is the numbering
what?
correct?
Mine or yours?
No, of course, we're talking about mine. Since your parent chain is not correct, so obviously your numbering is not correct
Yeah.
either. So I am talking
Yeah.
about my numbering. Is my numbering correct? Remember the rule? I told you the rule yesterday that the numbering should be in such a way that the branch is connected to a specific carbon atom, and that specific carbon atom should get the lowest possible number. So either I can start from this side, numbering this carbon atom as 1, 2, 3, which you can see in front of yourself, or I might start from this side. I can number this one as, okay, let me change the color then. This one is 1, this one is 2, this one is 3, this one is 4, 5, and 6, like this. So which kind of numbering is correct? The previous one or the one I just did? Remember,
The one
the
you
carbon atom which is
did.
connected to the branch should get the lowest possible number.
It's the one you just did.
Perfect. Why?
Because in this numbering, the number you just did is lower than the first numbering you did, which was 4, and now it's 3.
Perfect, which means this numbering is totally incorrect. So 3 is the correct one. If 3 is the correct one, can you come up with a name? Since I've done the previous part, so you, of course, can write the name, starting off with a number and then the prefixes and suffixes the same way.
Is it math?
So you need to start off with a number
Wait.
first. So the number would
Oh
be,
yeah, yeah, sorry. The number would be 3.
number would be 3, then there would be a dash, and yes, the first word would be myth. Continuing, what would that be?
And then continuing would be the methyl, right? Would be methyl.
Right, methyl,
And
and
then I
then
think yeah, so there's 6 carbons. It would be
yes,
hexane.
hex, right, hex and an ane, of course, hexane. Good. So perfect. The name would be 3, and then it would be methyl hexane. Okay. Now, I'm going to change it a little bit, and this time I'm going to teach you something new. What if we have two branches, right? And those have the same, two same branches on the same structure. How do we name it? So let's study another example now. This time the example is going to be different from the previous one. Let's say you have this chain, this whole chain, and then there is a CH3 over here, and then there is a CH3 over here. Now, this time, if you look at the whole chain, you do understand that this is the straight longest chain we can come up with. This is the parent chain. Now we have two branches, one over here and one over here. Now, if I start numbering from this side, this is 1, this is 2, this is 3, this is 4, this is 5. So one of the branch gets the number 2 and one of them gets the number 4. If I start numbering from this side, 1, 2, 3, 4, 5, one of the branches get number 4 and one of the branch gets number 2. So actually numbering does not matter from either side since we end up with the same name. All right. So what is the name going to be? Now, try understanding these rules. These rules are a little bit different from what we have been doing previously since we were only dealing with one branch at a time. There are two branches. In case of two branches, you need to mention both numbers. So there is a branch at 2. Of course, the smaller number comes first. And then there is a branch at 4. And then there is a hyphen. Now, since we have two branches, so mono means one branch, di means two branches, tri means three branches, and tetra means four branches, right? So these are number of branches, okay? So since we have two branches, so that is going to be dimethyl, right? Since each branch has one carbon atom, so meth, methyl, and yl, so dimethyl, and then it becomes pent for 5 carbon atoms, and then ane, dimethyl pentane. The point I'm trying to
Wait,
make is These two number means there are two branches, and dimethyl tells you that there are two branches of one carbon atom each, and the "-ile" represents its suffix, right? And then pent represents there are five carbon atoms in the parent chain, and "-ane" represents they are singly bonded. So every part of the name has its own purpose. Make sense?
Yeah, but I don't get where did meth come from if mono is one?
Meth comes from, actually, meth represents the branch has one carbon atom each.
One currently. So
Oh, this numbering. Okay, let me tell you something. This numbering meth, and meth represents number of carbon atoms, right?
yeah.
Mono represents or di represents number of branches. These are two entirely different things. A
Okay.
branch may have more than one carbon atom. A branch can have two carbon
Oh,
atoms. A branch can have three carbon atoms, right? And there can be two
yeah,
branches on a structure. There can be three. There can be more. There can be less.
yeah,
So actually, these prefixes stand for number of branches, and these prefixes, meth, eth, prop, bute, are actually representing the number of carbon atoms. So these are two separate prefixes representing two entirely different things. Make sense?
yeah,
Great,
yeah,
great. So this kind of naming is something you need to be familiar with. However, you do not need to understand this naming completely in order to be able to do it. All right? Which means
yeah.
actually Edexcel draws a boundary line over here. You should be able to understand this naming, even if you don't know how to name it, that's fine. Because you won't be asked to name substances like these in exams. You will only need to understand these names if these names come as a part of the question. Okay, so actually at this point, Edexcel becomes a little bit easier. So they give a leverage to the student that at least understanding how the naming goes is good enough for you. You don't necessarily require to write the names yourself for this specific type. I mean, more than one branch, of course. Good enough?
Yeah.
So now you know. I am going to repeat myself as a your part that you need to learn. You need to learn that if there are more than one numbers written over here, there are multiple branches on the structure. If there are multiple branches on the structure, there would be an additional prefix. Although meth itself was a prefix, but there would be an additional prefix representing the number of branches, right?
Yeah.
And you should be able to recognize this. That's about it. Even if you don't know how to write the whole name yourself, that's actually a part for A levels. That's not a part for IGCSE.
Okay, yeah.
Okay. So are we good with this example?
Yeah.
Okay, great. Now, another example which I needed to show to you was, okay, that's another example. We just need to show you these examples. You don't exactly need to um, to be able to write the whole thing. I'm gonna erase these numbers to make a little bit more space for myself over here for writing. Okay, getting back to it. I hope you understand this is the entire longest parent chain, right? This is one branch. This entire is another branch. I hope you understand we need to start naming from this side, because from this side, this branch gets the lowest possible number: 1, 2, 3, 4, 5, 6, 7. Now we have one carbon atom in one branch and we have two carbon atoms in the other. Now we have actually two branches. This one would become as a methyl branch, and this one would become the ethyl branch. I hope you understand the difference, right? since one carbon atom has meth and two carbon atoms are represented with S. Make sense?
Yeah.
Okay. So what I'm going to do is that I'm going to put the numbers over here. So it is 4 ethyl, 2 methyl, and since hep is 7, hep means 7, so that's methyl heptane. Make sense? That's how two different branches are named. You put the position for the first branch, you put the position when naming for the second branch, and from there on onwards, you continue with the naming of the parent chain. The branches are put in alphabetical order. So ethyl comes first because E comes first in alphabetical order, and methyl comes after since M comes after in alphabetical order. You need to be just familiar with it. You do not need to exactly learn all the rules, but you need to be familiar that how two different branches are named in the system so that you can at least read them properly. Do you understand the point?
Yeah. Is can you repeat the part where you name it methyleptane?
Methylene heptane. Okay, so actually two represents this carbon atom which is connected to another branch. This branch has one carbon atom, so methyl is the suffix for branch. Now we have the parent chain name left. Now the parent
Wait,
chain has all the way, yeah,
because it's methylheptane, isn't meth for one carbon? Why is there like
yeah, and that's the one carbon in this branch. This is the one carbon I'm hinting at. This branch has only one carbon atom. So this one is methyl. This one is ethyl. Ethyl is connected to fourth carbon atom. Methyl is connected to second carbon atom. And then the entire parent chain has 7 carbon atoms. So this parent chain is named as heptane. So we connect all the parts, 4 ethyl, 2 methyl, and heptane. That's what's written over here. Make sense? Or is it
I'm so sorry.
still confusing?
Yeah, it's confusing.
Okay. The only thing I wanted to show you was that if there are two different branches, they are named in two different manners. And those whole two different things stand before the parent name, parent chain name. So the whole parent chain is named as heptane. So the whole 4 ethyl and 2 methyl thing comes before the parent chain name. That's all I wanted to show you. Even if you don't exactly understand the rules, that's fine, since you're not required to do that in IGCSE. The only thing you should be able to distinguish is that two different numbers and two different names come before the name of the parent chain. That's all you need to know at this point. If you understand this, that's good enough. Let's not go into further detail because you don't require to do it in IGCSE. Do you get the point? And if you're still confused with the rest, let's not try solving it because it would take time. And since it's not a part of your papers, you will definitely redo it in A level. Let's keep it for A level. They actually do put it in A level for a purpose, since it's a little bit difficult for to understand for students at this point. So, and yeah, I agree with this bifurcation too. You might also agree since you're having a hard time understanding this one, right?
Yeah.
Good, good. So can I simply skip it since this is not the requirement of time? But if you're still curious, I definitely can answer that question. Your choice.
Can you repeat the last line again? Sorry.
Can I repeat what?
What you just said, like the last part, because I couldn't hear well.
I'm saying that we can simply finish it up. But if you're curious, I can answer your questions.
No, we can wrap
Answering
it
to
up.
your
Yeah.
questions won't help with this syllabus. We're done with the IGCSE part. It would just
Yeah.
quench your curiosity for A level.
No,
So
no,
it's
no.
your
The
choice.
this is if if it will make me like understand it a bit more, then I wouldn't mind going in it. But um if I can go in it without needing to understand A levels right now, then it's fine.
Yeah, you are right with the latter. Of course, even if you don't understand it, you'll be fine with IGCSE. You'll still take the best possible grade with it, and actually, you don't need to understand it. And
Yeah.
understanding it would might make it a little bit helpful, but of course, it would be something complicated at the same time. So it's actually a 50-50 ratio. 50% are the chances you would understand it better, 50% are the chances that it might confuse you more. So that's why I left it to be your choice. But it doesn't actually is required for IGCSE. So if we wind up right over here and we skip the rest and just move on, so it's a boundary line drawn by Edexcel, not by me. I'm just simply following it. So if you're okay, we can simply move on instead of just
Yeah, we can
discussing
move
the
on.
whole thing. Okay, good, good. All right. So I hope you understand the naming of alkanes. So I'm gonna wind up the whole thing. First, let me just put the image. Okay, good. And I'm gonna stop sharing and we're gonna get back to the book. All right. So the all the rules that I've explained over there, they explain the same thing over here. The longest chain in the molecule, how you're going to find a chain, and then you're going to start numbering. The numbering is from the end, whichever produces the smaller number. So you already know how do you name 2-methylbutane or how this name is 2-methylbutane. Now, if there are two same structures, it becomes 2,2-dimethylpropane. Now, I hope I have already explained it. Uh, I hope you understand so far. But you'd notice that they don't have the portion for uh, two different branches and naming them. That's why I was saying that they actually draw a boundary line over here. So, moving on, what they've discussed is that you can reverse this process. You can draw a structure from a name. All you have to do is decode the name. So what I'm going to do is that I'm going to get back to the whiteboard and we are going to practice this. I am going to write a name and you are going to try drawing a structure from it. And how to decode it, the name, I'm going to tell you the rules first. Okay. So I'm going to stop sharing over here. Let's get back to the whiteboard. Oh, not that. All right. So, okay. The names 2 methyl. Just a second. So I was saying 2-methyl pentane. Now, in order to decode the name, I suggest my students that since we started writing the name first from the branch and then the parent chain, so it should be the reverse order that you're going to work with. So in reverse order, work on the last part of the name first. The last part of the name tells you it's pentane. What does this prefix pent mean?
How was it? Uh,
Five carbon
four, no,
atoms, right?
five. Yeah, five
Five.
carbon
So
atoms.
what you're supposed to do is to draw. The first thing I write is draw the carbon skeleton first. Skeleton means you're only going to draw uh, the carbon atoms. You're not going to write hydrogen with them. So carbon atoms, right? 5 carbon atoms. That's what pentane means. 5 carbon atoms, pent, ane represented they are singly bonded. So 1, 2, 3, 4, 5 carbon atoms, all single bonds, pentane is completed. Now at position 2, I need a methyl. So let's start numbering them. This is 1, this is 2. So I need to draw a carbon atom. Meth means 1 carbon atom, and I'll means it's a branch. Now we are done with this whole thing, 2-methylpentane. All we are left with is to add the hydrogen atom. Remember, carbon can form 4 bonds, right? So what we're going to do is that since every carbon can form 4 bonds, so I suggest my students, and now I'm going to raise numbers, is to draw the bonds like these. This carbon can form 4 bonds, 1, 2, 3, 4. This carbon, 1, 2, 3, 4. This carbon, 1, 2, 3, 4. This carbon, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Make sense?
Yeah.
And then start
Yeah.
writing the hydrogen. Start writing all the hydrogens that you require. Okay, so this would be something like this. And then you can convert it into the structure. This becomes CH3. This becomes CH. And this becomes another CH3 at the bottom of it. So this is the bottom CH3. Then continuing, this is CH2. Continuing, the next one is connected to 2 hydrogens, so CH2. And then this one is CH3. There you go. You have either drawn the structure perfectly or the condensed formula. Or you can do one more thing. I hope you remember that I did these parts like this. So there are 5 carbon atoms, and on the second one, I have 1 carbon atom with the branch. So what can you do? You can actually count these bonds. This carbon has formed 1 bond, so we can easily write 3 more hydrogen with it. This can only form 4 bonds. This carbon has already formed 3 bonds, so I can only write 1 hydrogen with it to complete 4. This carbon has formed 1 bond, so I can write 3 hydrogen. This carbon has formed 2 bonds, so I can write 2. This carbon has formed 2 bonds, so I can write 2. This carbon has only formed 1 bond, so I can write 3. So you'll wind up like the same structure. So either you do it like this on a short note, right? Either you do it like this whole thing on a shorter scale, or you draw the entire structure and then condense it out. It's entirely up to you. So there are actually 2 different techniques that we can perform. Either one can get you towards the right answer. So it's entirely up to you which one you choose. Students, as beginners, tend to go with this one. Since this one easy, you just need to draw the 4 lines with any carbon atom that you're given with. So it's easier to come up with the whole structure. Either you show the displayed structure or you write the condensed formula, you get your mark, of course. If it's not specified in the exam, if the question is open-ended, of course it's going to work that way. Good enough?
Yeah, good enough.
All right. So can we practice this? Means I can give you another name and then you can go on with drawing the structure. It's entirely up to you whether you'd like to draw the displayed structure or the condensed formula. Totally your choice. Because both ways you're going to get to the same point. So I'm going to save this as a picture and I'm going to give you a name. If you're done writing, can I do it?
Yeah.
Okay, good. So I am going to export the image. I am going to clear this entire thing up. Remember, carbon can only form 4 bonds, no less, no more. In fact, going to move this entire area. Let me give you an example. Um, 2 ethyl hexane. Okay, let's try drawing a structure. Are you able to annotate?
Yeah, wait, I'm just trying to get it in my head how to do it.
Sure, sure. Take your time. Fine.
Can I like because sometimes the audio is not coming clear. Just 1 second of yours. So hold on a minute.
I didn't get it. Do you need the previous picture that I just exported?
No, no, hold, it, okay. Because it says hexane, that means there's 6.
Perfect. Yes, there are 6 carbon atoms.
So you would draw 6, and then A means it's single bonded,
Right.
and then um we have to number them.
Yes, of course. In order to make sure that you get the number of the branch, because the branch is present
Um,
at the second carbon.
second or
Oh,
is there
for
no
my
place that
my bad, my bad. It's definitely it can't be on the second number, so I am going to change the
oh,
number. It's actually present at the third number.
yeah, third.
Yeah, I just figured it out. I was supposed to write 3 and I instead wrote 2. Now that's correct. So third carbon atom, the branch is present on the third carbon atom.
And then
How many carbon?
because I mean wait, it would be
How many carbon atoms would the branch have?
2
And how do you know that?
because of ETH
Perfect.
yeah,
Go ahead, draw it. Great. So you're going to draw step by step 2 carbon atoms.
there.
Great. And now you just simply fill them up with hydrogen to get your structure right. And that's actually the last step.
Wait, hold. Hydrogen would be uh, here. Wait, hold. Here. here and here, right?
right? Since you need to complete all four of those, and you're going to do the same with all the carbon atoms. Great. Keep going on.
Can I erase the numbers?
Yeah, yeah, sure. Go ahead. If that makes the whole thing easier for you, go ahead. Erase the numbers.
Not the numbers, but you put the H's there, right? The hydrogen there as well.
Right.
Wait, that is a bit odd. Is this it?
Your structure is still missing one hydrogen atom. Now that's good.
Yeah.
That's it. Perfect. You've drawn correctly. So now you know how to convert the name into a structure. Good enough?
Yeah, good enough. Yeah.
Good. So I am also going to export it as a picture. Great. It's about time. So